This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Well, hello, everybody. I don't think Lee is on yet, so I'm going to go ahead and say our date. It is August the 5th of 2026, and we are here to talk about Lesson 2, number notation. And what we're trying to do this year is to take a look at that classically. So let me share my screen. Learning to do one thing at a time. All right, so there we go, number notation. And so I wanted to start the first couple of weeks just to take a minute to talk about where do we find our Math Map resources. That if you have joined us here on the book club for the first time, I want to make sure that you know where to find things. The book club archive is going to be one of your best resources. You can find that in the companion. There will be links in the lessons to different book club episodes. You can find that at leebortons.com or on YouTube. You can also find it there. And just as a reminder, we have episodes or series that were about the exordium and the charts, episodes that were about using that in community outline with using that with complex. So if you're a tutor and you're going, what does this look like in community? That might be a good resource for you. And then last year we talked about what does it look like to use that at-home outline, whether you're a foundations parent and that outline is actually in your booklet on the Math Map page, or you're a challenge parent and following along in the guide. What does that look like? And so we did that last year with integers, fractions, and monomials, talking about what those pages look like. Because I know this question has come up recently, I did want to just really emphasize that when we talked last year in our book club, we spent quite a bit of time talking about the I pages. And so here's a quiz for those of you who have been doing this for a couple of years or more, because I know you're out there. What is the title of the I2 or I squared page?
Invention?
Invention. So what are we practicing on the invention page?
Taking inventory.
Okay, good.
We're
practicing our skills. We're practicing
our skills, our 5 common topics. I heard somebody say that, right? We are practicing the skills of invention. Are we worried about learning the math that is on that page? No. It may be that we learn some of the math that's on that page, or that it helps us to put some things into context, but the goal is not to learn the math on that page. That page is not designed to teach you math. The goal and that page are designed for practicing the skills of invention. How about the I cubed page?
Memoria
and arrangement. So what are we practicing on the memoria and arrangement page?
More skills,
the skills of memoria and looking at arrangement. Yes, so especially our names, our naming, attending, memorizing, expressing, and storytelling. That is a great page for practicing those skills. Is there math that might be helpful to learn there? Yes, but guess what? There's nothing on those pages that you're not going to see somewhere in the lesson pages over the course of the 30 weeks. So don't stress about the content that's on the I squared and I cubed pages. It will come up again in the lesson pages. Instead, use those pages to practice your skills of learning so that you can use those skills of learning to interact with the math on the lesson pages. So I just really wanted to encourage everybody, because if you're a first-time parent and you're looking at those pages and you start to think, I've got to teach this math, that is not the goal, right? That is not the goal. The goal of those pages is just to practice those skills of learning. And do we have to practice every skill every week? No, right? it's quick, right? We spend a lot of time on these things on the book club because I'm usually trying to give you lots of different examples and lots of different ideas. But remember, you can pick one skill to learn each week and just keep practicing that skill. Or maybe your goal is just to be able to list what are the skills of invention. That's okay. So take a deep breath if this is your first year and you've looked at those pages and you've maybe just panicked a little bit. The math doesn't matter, not on those pages. It's the skills that we're focusing on. And it's quick, and we're just trying to remember that we're looking at skills and we're equipping our children to learn whatever it is that is placed in front of them. This year's book club, we are going to be looking at the lesson pages. So we're not looking at the rest of the curriculum. We're just looking at lesson pages. We are going to use rationals and binomials. And my goal, because Nicole has really pushed me, right? She's always saying, well, how would you do this classically, right? Is to really think through, what does this look like to lead at home in a classical manner? I don't have all of the answers, and I cannot tell you that I have done this perfectly in my own home. So I'm trying to give you a structure within which you can work to really focus on your students. And one of the things that you're going to notice is that I don't try, because we don't have time in an hour, right? And guess what we're going to do? We're going to look at 4 pages in 1 hour. Yes, with 2 different domains, but if you're doing this with your children at home, right, you might have more than one domain. Do we want you to spend more than an hour on logic? Nope. So I'm not going to have time to classically lead you through every section that we look at. You're going to see that we're going to pick and choose what it is that we look at. Now, where would it be helpful as a parent to keep track of the things that we've looked at more deeply and the things that we didn't?
On your math map page on the front.
You might, on your math map page, you could do it there. Where else could we do it?
Could use the charts.
We could use the charts, and we can use the lesson pages, right? So as a parent, you can make notes. You can use these as resources for you as a parent to remember what it is that you've covered, so that next year when you come back around, you might go, I don't want to do the same thing every year for 5 years in a row. We want to make sure that over 5 years, we're going to pick some different pieces, right? So I just really want to encourage you. There is no perfect way. We're teaching classically. Our goals are to equip our children to learn anything that they need to learn and to be lifelong learners, and hopefully to love learning, and maybe even to love math, right? And so that is our goal. The math that we're learning is great, right? It's going to help us to know God in a new way. But we don't want to get so hung up on that we become stressed or fraught or pass on to our children stress and worry and anxiety, right? We want to help them realize that we can learn this way, and we don't have to learn everything every year in depth. And then I just wanted to remind you that whether you're attending live or not, you can send questions to the Math Map at classicalconversations.com. If you're trying to find something, Babs is your best resource for finding specific things. I don't know how she knows where everything is, but somehow she does. And so she can help connect you to the resources you need. And if there are questions that you would like me to answer live, we are happy to do that. So if you're not able to join us, you can send those questions in, and we will work those in to our weekly conversation. So we won't go this in depth every week, but I just wanted to take a minute to talk about that for those families who maybe are joining us for the first time. So as I said, I am not perfect at this, but I put together what you're going to see the format for tonight is, or this afternoon, because not all of you are in the UK, that I'm going to look at the page tops of our rationals and binomials together. and I'm going to ask some questions that are perhaps more geared to if I was having multiple students together. Then I'm going to alternate between rationals, and then the next page we'll look at binomials, and we're going to go through some different questions on those where maybe I might be working with one student. That doesn't mean that you can't work with one student on these or two students on the other or three, but I'm trying to come up with a way that we can sort of organize this. And so your feedback is welcome. The other thing that you might notice is that we are going to look at pages 5 through 8 this year. So I might say page 1, 2, 3, and 4, and so forth, but try to remember we're actually looking at pages 5 through 8. Since we have resources in the companion for pages 1 through 4, there's video resources for all of those pages. I thought that it made more sense, instead of doing those again, that we would look at pages 5 through 8. So for those of you that are like, okay, let's look at the next set of 5, we'll be doing that this year. So again, feel free to share your feedback because this is a little bit different. And certainly please participate. So as we look at our page tops here, the first thing that I would say you want to do is to read together. Right? We're not going to read together here. I think most of you can scan and see that, but especially with your students, especially if they're developing readers, reading together and helping them to know how to read that mathematics is important. Now, if there is something on these pages that you don't know how to read, please either make a comment and Babs will flag it for me, or just speak up and let us know, raise your hand. And so we can read those things aloud. At a minimum, I would say always read the instructions together, simply because it's very easy for both us and our students to just jump in without reading the instructions, and we start doing more than the exercise is actually asking for. So again, reading together is the place to start. Then we're going to practice attending, and I'm going to ask you what is familiar and what is unfamiliar. So go ahead and just use the chat and put some things in there. What are some things on these pages that are like one thing that's familiar and one thing that's unfamiliar? Or you can do one or the other.
You want me to start? You want me to read some things, or you just give me a minute?
Yeah. What are some things that are popping up?
Okay, so the domain names are familiar. The
Good.
Euler diagram is familiar. We've done that on previous pages. The dot is familiar. That's cool.
Good.
Multiplication law from foundations.
Excellent.
I think that's all I see so far.
Is there anything that is unfamiliar? You don't have to. Oh, sorry. Go ahead.
I don't know if this is familiar or not, but they say the phi sign or the phi sign on complex.
Yeah, I was going to say that I'm not sure what the numerical representation of the phi sign, but these, all of this after multiple years is pretty familiar. So that's kind of fun.
That is good.
Another unfamiliar, the colorful letters, what do they mean?
Okay, that's good.
Transcendentals might be unfamiliar. A divided by 0, depending on circumstance.
Yeah, that word depend give me anxiety.
Unfamiliar in binomials, the negative square root. And as a first timer, the Euler diagram is unfamiliar. I can remember that. Yeah.
So there's a great way, if you are doing this with your students, first, right, always starting with what's familiar to you. And I love that somebody said the dot. Even if you don't know anything about the point, right, you're familiar with dots. All of our kids have done something with dots. And so starting there, you can go, okay, you're right. that dot is familiar. Let's find some dots. Well, what do you think they mean? Now let's connect it to something that's unfamiliar. Do you know what a point is, right? Maybe I don't, right? So that is a way, that is an entree into that conversation, right? If you have a student who says, yes, I've seen this Euler diagram year after year, and another student who goes, I don't know, right? Then now I can say to my familiar student, okay, can you explain to your brother or sister their Euler diagram? And they might go, well, the outside box, right? Think about boxes, right? If I have a red box inside a pink box, everything that's in that red box has to also be in the pink box, right? And they could even get a box and show their sibling, right? And then they might say, hey, look back at your math map page. Do you see those colors and the colors here? And do you see that N, Z, Q, R, and C that are there on the math map? What can we match those up? Oh, wait, N matches with naturals and Z matches with integers and Q matches with rationals. I wonder if those are symbols that represent those, right? So this is a great way to take something that is unfamiliar and somebody who says, well, I'm a little bit familiar with this, and let them compare and talk. Now, again, if I have multiple students at the table, something that you can do is say, compare exercises in your domains. So let's look at the Euler diagram, right? Can somebody tell me what is the same in both of those domains? You
They
can
both
put it in
have
the
a
chat
Q.
or speak up.
Mhm.
The Q, Z, and N?
Good. Yeah.
Oh, here's a good question. Is there a name for our domain letters? I've been calling them fancy N, fancy Z with my kids, but are there actual names or are they just called NZQ?
No, if a mathematician was to see that, they wouldn't think N, Z, and Q. They would just go, oh, naturals, integers, and rationals. They would just immediately say what they represented. But that's good. So we see there what's the same, right? That they have that Q, Z, and N, that piece of it fits into, right, what's there. So what's different? What does binomials have that's different?
They have the top, the complex and reals.
Yeah. And what else? Reals, complex,
Transcendentals.
transcendentals, imaginary, irrationals. Yeah. So notice, even if I don't know what those things are, I can still compare, right? So my younger sibling or my less familiar sibling can take a look there and go, this is where I'm headed towards. I see where what I'm doing fits in with what my more familiar sibling is doing, right? If you don't have a sibling to do that, right? As a parent, if you wanted to do the same type of comparison, you could flip to perhaps page 1 and go, how is page 1 and page 5 similar, right? What's alike on these two pages, and have that same type of experience, just comparing different pages versus different domains. Or you could get out what they did last year, right? If you're a parent that saves things, you could get out what they did last year and say, hey, this is what you did last year. How much of this is like what you're doing this year? And allowing them to compare that way and gain some confidence. So now let's take a look at, we're in booklet 2. This is lesson 2 this week. And this is rationals. So I had rationals and I had binomials up. And so this is rationals. So let's take a look at the rest of the page here in rationals. So again, I would ask my student to read. Now, as we think about how do I do this with multiple students and when do I let them work independently, when do I not, that's going to depend on every family. But a great way to have that conversation as a family is maybe look at those page tops together and then say, okay, we're all going to read our instructions together. Right. So Babs, what are you going to go and do? And Babs reads her instructions. And then Sarah, what are you going to do? And Sarah reads her instructions. And that way I know everybody's read their instructions. Now, my student who is more independent minded, perhaps I let them go and work through the rest of the page while I work with my student who needs a little bit more help. If they both need help, then maybe we just continue to work together. Or if they're both independent, I let them both go and do some and then bring them back at different times to check in with me. But as we're doing this and we look at this, if we want to help emphasize one particular thing and dive deep onto one particular thing, then what we can say is, okay, let's attend. And again, I'm going to start with what is familiar and what is unfamiliar. So this time, I'm going to skip asking you all to name something that's familiar, but go ahead and take a minute and tell me something that is unfamiliar on this page, either a concept or an exercise.
I just still struggle with the ratios.
Okay, so we're going to sit here and we're going to go, the ratios just are not familiar to me yet. So let's talk about how do we do this? So maybe there's a bunch of things that we've listed, but we've picked ratios for this page. That's what we're going to focus on. That doesn't mean I'm not going to ask you to go and try to do other things, right? But if I wanted to focus more closely, then what I can do is come in here and say, we're going to look just at this. We're going to pick this out of all the unfamiliar things you said. This is what we're going to pick. So let's start by naming what we know. Right. So what can we name on this row? So I'm going to highlight here. So we're looking at just this section here. What do you know? What can you name on that row?
So
I can
I
name all the
see,
numbers.
Good. We can name the numbers.
I see that the 4812 kind of like even numbers, and 10 and 50 are even numbers.
Good.
And then the second one and the 1525s, I see them all in multiples of each other.
Good. Good.
We're also comparing negative and positive numbers.
Okay, good. So we see some negatives and positives. What are some of the symbols that we have here?
Somebody said it looks like the analogies book, but with numbers instead of words.
Okay, so what do we call these in the analogies book?
Colon.
Okay, so we have a colon. There's our symbol. There's one symbol. What's our other symbol?
Equals.
Equal sign.
Equal signs. Okay, and if I was looking at my analogies book and I saw words with a colon, now they don't use an equals, but what do we call them there?
As to.
Yes, we have different language, right? Is to, we call them analogies. All right, I know that seemed like too easy since it was the analogies book, right? So here we're calling them ratios. And then when we have the equal signs, we start calling them proportions, right? And then in analogies, we use different language, but it's a very similar idea. So now I can sit here and go, okay, well, if this was analogies, this is how I would name it. But for math, I'm naming it a little bit differently, right? And then now, is there anything there that you don't know? Is there a symbol, a number? Is there anything there that you don't know that we need to define?
Well, I didn't know that it was still just called the colon. So now I know.
Perfect, right? So that might have been something where you go, I don't know what that's called. And so we may look that up, or we might ask somebody, right? We bring it up here and we go, oh, it's a colon. It doesn't have any special name. And then that makes us feel better because now what did we just do? We took something that was unfamiliar and we made it familiar because it's the same word.
So somebody asked, do we read it differently here than we do in the math book?
Not really. I mean, you could say 4 is to 8 as 1 is to 2. -9 is to 12 as, right? We can still read it that way. It's still analogous. It's just that when it's math, we can operate on it a little bit differently, right? If I wouldn't necessarily, right, try to like simplify by canceling factors and things like that if I have words. Right? Like if I had 66 over 6, I wouldn't go, oh, I have the word 6 in both places. I can simplify, right? We know it doesn't. But we can use this, that language from analogies as a way to compare the unfamiliar to something familiar, right? And so that's what the next thing is. Once we have defining what we don't know, right? What are the things we need to define? What can we compare this to? And we're all going, well, we can compare this to analogies, right? If that's something that has become familiar to us, we can compare this and go, oh, this is similar, right? We could look at another domain. We could, right? So in this case, I might look back at fractions and go, what did this look like in fractions? Did we have this exercise? Where else have we seen this? I might look at the chart and compare what I'm looking at here to where I have my fraction chart in lesson 3. So that's jumping ahead a lesson, but maybe I remember that that's there. And so I say, well, let's compare. And then my students might say, oh, well, all of these fractions can be written as ratios. Can the ratios be written as fractions? Could 4 to 8 be written as 4 over 8, right? So again, I might take something that's, I'm taking that unfamiliar and connecting it to something that's familiar. Then I look at patterns. And some of the patterns that we notice might matter. Some of the patterns we notice might not matter, right? But we can say, what patterns do we notice? So somebody just said a ratio is just division, right? Yes, right? Now, the use of a ratio, now here's where ratios are, we don't get into it here. So I'm giving you way more than I would expect you to give your student. Division is very, very useful. And we have different ways of talking about division in order to communicate different ideas. So in this case, if I am considering ratios, I can just write them as fractions and I can just compute with them as though they were a fraction. But they give me the language to talk about relationships between rates, between quantities. That's the power of a ratio, is that it usually is communicating a little bit more than just a number. So here we're just seeing numbers because it's just nice and straightforward. But when we use ratios in the real world, right, they're usually communicating some kind of relationship. And so that's where we see this pattern that's emerging here, that we might say, oh, well, 4 to 8. Well, what's that the same as, right? Well, why is it the same as 1 to 2? If there were 4 adults and 8 children in a room, right, why would that be the same as 1 to 2? Does 1 to 2 describe what was in the room the same way? No, but it does describe, right, how many adults are there for each child, right? So these are, as our children are asking deeper questions, right? So my first year student may not ask those questions, but my older students might start to dig in a little bit deeper there into what is the meaning of a ratio? Why would we use ratios? So again, we're Then we're going to look at patterns. We can look at that example and see that, right? So if we're thinking this looks like division, it feels like fractions, 4 divided by 4 is 1, 8 divided by 4 is 2, that makes sense to me. It's not quite as straightforward with 9 to 12, or sorry, negative 9 to 12, right? There, it may be helpful to have your student write that as a fraction, negative 9 over 12, so that they can see that negative 9 is negative 3 times 3, 12 is 4 times 3, 3 over 3 is 1, so I'm left with negative 3 to 4, right? And then see if they can see the pattern to continue on. And then the last question you can always ask is, do you know any laws or properties? So notice these are very generic questions that I can ask pretty much about any of our exercises. So for that student who wants to learn more, this is a way you can classically lead them through that conversation. Questions?
I think I still struggle with knowing that my youngest child is going to want to know the answer to these problems. And no, I'm okay with we've gotten okay with, like, let's go find the answer, or let's go find the things that we need to find the answer. Um I think I'm still struggling with how to make sure they're getting it. Like they could do I'm just struggling with I know
So
I've been doing it for 2 years, but I'm still struggling with, like, not teaching them didactically on these little, what I think of as little, like, main things that they should know how to cross multiply. They should know how to, do these.
right. So one, I would say, if you find that your student is having a hard time simplifying these, that's where I would go separating out, okay, what is it? What is a ratio? What does it tell us? How do we operate with it? Um, how do we write this in different forms? How do we write it as a fraction? That's one skill that doesn't relate to the calculation. Then we have calculation skills. And so it may be that I get to this and they go, I can't do this. And then that's where I would go back to what we talked about over the summer, where I said, okay, when you encounter that time where they go, I don't remember how to simplify a fraction. Okay, well, let's go watch this book club and let's remember how to practice it. Okay, now I remember. So now we're going to go through and I'm just going to have you, right? We're going to spend 45 minutes on your lesson pages. You do as much as you can. And the last 15 minutes, you're going to play this game with cards and practice your ratios, right? That's what we're going to do. We're just going to practice simplifying ratios until you feel like, oh, I really am confident now that I can say 15 and 25 have a common factor of 5. 10 and 50 have a common factor of 10. All right. That mental quickness is going to come with practice. So that's where I would say, right, to go back and identify those skills and then practice those specifically as you need to. Right. So
I guess I need to keep in the front of my mind that is an option. Like, not getting
yes,
the answer is an option.
it is. And I think so. We had I spoke in London now nearly 2 weeks ago, and we had a really great conversation there because a lot of the families have been using the math map now for several years. And we were talking about those students that are maybe new to the math map, or they think they know everything, or they want this. And we as a group in that conversation realized that a lot of the struggles that the students were having were not about the math map. It wasn't about understanding. It wasn't about the math. It wasn't about the classical method. That a lot of it was a heart issue, that they wanted to do it their way and not the way that mom said, or they wanted to do it in their timing, and right. And I know from my own parenting that a lot of things were heart issues, not academic issues. Right? And when that student goes, well, I just want to know the answer, that's a really great opportunity to practice not getting the answer when we want it, right? Because how many of us have prayed for wisdom and really wanted God to just kind of like shine down the sunbeam from heaven on the path that we should take, right? And we're like, God, just show me, just right now, right? I want the answer. And he says, wait. And so this is a small way that we can help our students to learn, right? To persevere when they don't get the answer, when they don't know the answer right away. Because I think that that's a spiritual skill, right? That we have the opportunity to develop here. So,
We do have a couple questions in the chat.
okay.
So where do we use ratios in real life? That's the first one. Some people have commented cooking and drugs, pharmacy, good drugs, not the kind that or like a nurse was talking about that. So that's one question. Do you have any other examples of ratio?
Well, again, anytime I'm looking at relationships. So if you have boys who are interested in cars, it's all about, right? Anytime you have gears, they're all about ratios, right? The gear ratio is telling me, right, how many teeth, right? So a smaller gear how do those gears either increase speed or decrease speed, right? How do those gears work? That's all about ratios.
I remember years ago, there's the Food Channel, the Sandwich King. He's always talking about bread to meat ratio. And if you have too much bread and not enough meat, that doesn't make a good sandwich. He has a golden ratio in mind.
I like that. Well, we were talking. Go ahead.
I was going to say, I just wanted to answer this question a little bit. I want to encourage you not to get caught up in answering that question when your student says, when am I ever going to use this in real life? You could come up with a long list of things. It doesn't matter. What they're really saying, to your point about it being a hard issue, is they don't want to do it. And one of the things that I've started saying to my kids is, well, why do people go to the gym to lift weights, right? When are they going to lift weights in the real world? Right. The point is not what you're learning. The point is the skill, right? We've been talking about the ability to make these connections, the ability to be a problem solver, a deep thinker, to focus, to turn a problem around in different ways into your head. And so when my kids say, when am I ever going to use this in real life? I say, you might not, but you're using it in the gym right now.
That's great. And if you have those things, I think that's great, Nicole, to not get distracted, right, and go down that path, but to say, hey, this is really fascinating. This is something that would really be fun. So have a whiteboard, and you can do it for all the strands, right? For all of the things that you're doing that you want to come back. Let's come back and look at ratios later. And maybe we're just going to become really attentive this week and see all the places that we see ratios, right? And maybe that's what our family is going to have fun with this week, is being on a ratio hunt. And so have that whiteboard or whatever, wherever you put your notes, right? And just put ratios and then just attend to that. And then see if at the end of that, by finding the patterns, where are all the places that we saw ratios talked about? What do you think a ratio is? And let them define it from, right? That would be the classical way. So, yeah, I like that. Looking at that in week 29, right? All of these things where your kids go, well, I do want to know more about this. Okay, well, let's look at that this week. And then, hey, let's go ahead and take some space in week 29 to put down what we found out about ratios. All right. So again, notice we only talked about one thing on this page. Now, my students might have gone through and done work on the rest of it. They may have copied from the answer key. They may have worked together, but we're just going to pick one or two things as we're going through that we're going to go more in depth. Because notice we've already hit 40 minutes, well, maybe 30 minutes into our time together, and we've only gotten through one page. So the rest of their pages, they may be working through, and you're not going in depth, right? So let's take a look here at the next page.
Can you
Right,
take
so
some questions first, though? We still have some in
Yeah.
the chat. Okay. One, I think there's an answer, so it's probably sufficient, but the difference between a unit fraction and a proper fraction, that was a question. And then another one is, as the parent, if I don't know anything about, I think you've kind of answered this a little bit, but as a parent, if we don't know anything about ratios, where do we go to find these explanations? So I think you kind of just alluded to that, where you don't necessarily have to tell them, right, everything.
So a unit fraction is a fraction that has one in the numerator, because I'm saying I have one of that type of fraction, like 1/4, 1/5. Those would be unit fractions because I just have one of them. And also because it can define a unit. So if you don't know what I mean when I say that, go back and watch our summer series where we talked about how fractions can be units, right? And so when it has a 1 in the numerator, a proper fraction just has a numerator that's less than its denominator. So it could be 2/3, right? It's not a unit fraction. All unit fractions are proper fractions, but proper fractions just have a numerator less than a denominator. Then we also talk about identity fractions, and identity fractions are where our numerator and denominator are the same, and so they equal 1. So we might be tempted to think unit, right, means our fraction equals 1, but we're calling that the identity fraction because something times that equals itself, because something times 1 equals 1. And then it's a really great question because I know people go, well, you just know this. I know it just because I've done it for a long time, right? The reality is that very few people, like if you go and talk to math PhDs, nobody has really studied what a ratio is in depth. They've just used it a lot. And so think when you see something that you're not familiar with, right? You can become familiar with it by looking for it yourself. You can go and look in the companion. You can go and look up the definition there. You could look in the charts and see what we say about ratios in the charts. And then again, just become attentive yourself and work with your students. But another great thing, and this is what I really want to encourage us all to be embracing and enjoying, is that the math map allows us to be doing math in community. The pressure is not on Yating or Kristen or Nicole or Babs to know everything because you're doing it in community. So you can go to your community and say to the other moms, I just don't get ratios. How do you teach it? You can come to the book club and go, this ratio thing is it just has not clicked for me. Has anybody else had that? What helps you make it make sense? You can go to the challenge directors and go, hey, how do you guys talk about ratios in challenge, right? How have you done that? You could talk to the challenge students, right? So notice that now you have this whole network of people that you can go to and talk about ratios because everybody's talking about these ratios. Everybody's doing it with the same language. And now we can sit here and go, right, what does this mean? How did you teach it? How did you practice it? Where did you find it? And again, you can always email us at themathmap@classicalconversations.com, and the amazing Babs will help you find those resources. So I'm not going to spend a lot of time because I'm really trying to model for you what this can look like at home, right? So I might have just done page 5 with my students, and we've taken a deep dive on what does it mean when we have a ratio. And so now I say, okay, we're going to go quickly here. We're going to read, and we're going to look, and we're going to notice what's the same. All right, everybody's told me one thing that's the same. Good. Do you have any questions? Right? Yating, do you need Nicole to help you with your lesson? Right? No? Everybody thinks they can do this page? Good. All right, let's go ahead and look at the rest of the page. And notice the same questions are here for binomials. And so as I look at this binomials lesson, right, I'm going to start off with what's familiar and what's unfamiliar. Again, we're running out of time, so we don't really have time to do a deep dive. So if Kristen says, Mom, I don't get any of this. It's been like too long over the summer. It's week 2 and I just don't remember. And I might say, okay, well, listen, I'm going to fold your solutions in half and you can do the left-hand side, copying it from your solutions, and then see if you can do the right-hand side. Right? And so I want you to try that. Notice now I'm setting her off on her own and we're not doing that deep dive. And the same. So because I want to make sure that we have time for questions, I'm going to click through here. Right? And it might be that in your homeschool, you just get through 2 pages. And that's okay. Right? One of the things that I want you to hear is that you have the freedom to lead mathematics education in your home the way that works for you and your students. And that can look different from day to day. It can look different from week to week. It can look different from year to year. It can look different from student to student, right? That you have the freedom to lead mathematics education in your home. And we are here to support you in how you do that. We're not here to give you a script. We're not here to give you all the answers. We're not here to tell you, right, everything that you should be doing to make this right. There is no perfect way. We're learning math classically. And so I really want you to feel equipped and to know that you have the freedom to lead math education in your home. But we're here to help you. Nobody's asking you to do it on your own. So again, I'm not going to talk about this every week, but I just wanted to highlight this. When we have multiple domains that are sitting at that table together, and we don't want to try to be mom, right? We're not trying to teach math individually anymore. We're bringing us together at the table. We can read our math together. That is the most important thing, is developing that ability to read a math page. We talk about what's familiar and unfamiliar. That's helping us to attend. It's helping us to use our memory, right? So we're attending and we're using our memoria to say what's familiar and what's unfamiliar. We can let that more familiar student help the less familiar student. Then we can pick and choose how we work individually with those students, whether we keep them together, whether we break them up. With the students who are more unfamiliar, we want to stress reading the instructions and reading mathematical language. As students gain in familiarity, we can ask them to do what's familiar first and then work on the unfamiliar. And we can always, I didn't put it here, right, but we can always add in computation that is specific to where they need to be shored up. We can always add that in through games, flashcards, and so forth. Again, we're here to support you. So I thought that each week I'm going to highlight a different thing on here. So this week, let me turn off my pen. Here, if you go into the companion and you click up here on the math map, this is the page that you get. Learn more about the math map. And you can read about what is the math map, why use it, where to use it, when to use it, how to use it. There's a note from Lee that she wrote early on. There's a welcome from all of us. There's a thing about math map and classical education. This is a really great resource, especially if you're new or if you've never read it, to go back and revisit that. And then next week we will be, that's funny. Sorry. Right. Next week, we're going to look at our comparison lesson. So please come back next week for comparison. And now we have 10 minutes. I have to be done at 2. I've been given a hard stop so that you can all go to the Latin book club. But we have 10 minutes and I am happy to answer any questions, whether you want to go back and look at pages that we didn't get to, or whether you have questions from another lesson.
I have
I
a
think-
question. Oh, go ahead.
I think I got all the ones that were in the chat. If I didn't, you might need to speak up because there were flying keyboard warriors putting questions in there. So, but I think I got them all.
All right, Sarah.
I have a question on careful calculations with my decimals student. Could you maybe model for me how I would show? Sometimes I know how to tell her, but I don't know how to explain the how behind it. So with a negative 6/4 on the careful calculations page, it had her do the opposite, which was then 6 in the numerator and 4 in the denominator. But I'm not sure how to explain to her the process of going from that to a decimal.
Okay, sure. So let me turn on the pen. So when we have 6/4, and we want to write that as a decimal, to me, this is how I do it. If I don't have it in my memoria, so first I would say, can we simplify this? And if we see that this is 3 times 2 over 2 times 2, here's my fraction that's 1, and it simplifies to 3/2. Now, it might be so that's in her memoria. I know I left off the negative. I would always do that. I would just say, don't worry about the negative. Let's just look at the magnitude, and then we'll figure out the sign. So
How
it
would you
may
get her to do that, though? Would you just say, for the 6, what do you multiply to get 6?
Yeah, so when we're looking at simplifying, that's where so Babs maybe can tell you which week it was where we talked about simplifying fractions this summer. So I would say anytime that I have like 6/4, I would say, okay, so if we need to find some common factors, right? So can we write 6 as the factor of 2 numbers or 3 numbers, or right? And so hopefully then she might say, well, 6 is 3 times 2. Okay, great. So now don't worry about 6. Let that go away. Let's think about 4. Can we write 4 as factors? Well, 4 is 2 times 2. Right? And so I would do that independently. You could even take that and put it somewhere else. Like leave 6/4 and then do 6 and 4 and work it separately so that because sometimes you see it and you're like, oh, there's all of these pieces. How do I keep them straight? And so working it separately. And then you say, okay, well, do you see an identity fraction there? Now, in this case, because with 3 times 2 or 2 times 4, I would have ended up with it. If not, you might have to say, can you rearrange it so you can see an identity fraction? Right. So let's say it had been 3 times 2 over 5 times 3. Right. Well, if I rearranged one of those so that the 3's lined up, right? So I can ask that question. But now I can say, do you see an identity fraction? Right. Well, 2/2 is an identity fraction that equals 1. So now I can just see that this is 3/2. So for some students, that might be enough for their memoria to ping. If not, and we want to help them to see what it is that we're doing, there's a couple of ways, right? One is to just look at it as division, right? So 6 divided by 4. So if I write this with my division house, I have 6 divided by 4. And I might say, okay, how many 4s in 6? There's 1. 1 times 4 is 2. Now I have to put my decimal and annex it. Oops. Sorry. There we go. So I have to make if I try to make a dot, it thinks I'm tapping. So anyway, so yes, so there's my decimal. I'm going to annex a 0. So I'm going to bring my 0 down. And now my decimal point, I have 5 4s and 20. And so there's my decimal equivalent of 1.5. So that's one option. Another option that I can do is I can look at this here and I can say, okay, here's my number line, right? And if I have fourths, and I went, this is 1, this is 2, and I have 6/4. I have 1, 2, 3, 4, 5, 6/4. Oh, look, that gets me to 1.5. So that's another way I can explore that. And then I would say, okay, but remember I had a negative 6/4. So would it be negative 1.5 or 1.5? Right. Well, if I had negative 6/4, I would have gone this way. And so it would be negative 1.5. So I can use my number line in both cases. So does that help?
Very much. The number line was a bonus. Thank you.
You're welcome.
Can I just
Other
add,
question?
can I just add quickly for that
Yeah.
one? When doing the factoring where you did the 3 times 2, what I often ask my child is, what's a number that you know can go into both 6 and 4? And that's where we start. So then we start with the 2, and then we do, okay, so 2 times what equals 3? And then 2 times what equals 4? So then I know we have that common factor, so that might
Mhm.
be a helpful way to do it as well.
Thank you.
Any other questions? Well, thanks everybody for being here. I think Babs is quickly scanning through to see if there's anything else in the chat that we need to answer. But I really appreciate everybody participating, and please let me know if this format is working or not. I think in order to be able to take those deep dives, we probably won't get through 4 pages every week. But I'm happy to answer questions that we don't get to. So if you have those, please make sure that they find their way into the chat, or, send them to Babs, and that way we'll make sure that we do answer those questions. But again, the goal this year is to really try and model for you and for me, and right together to wrestle with what does this really look like to use the classical method to learn mathematics, right? Nobody else is really doing this. This is a new idea, because nobody's really said, how do we do this, right? How do we help our students learning math using the classical method this way? So I really want to encourage you to continue to wrestle with us through this, and I thank you for being here. So have a great afternoon, wherever you are. Have a great evening. And I will look forward to seeing you all next week when we talk about comparison.
Thank you very much.